Let's see. Am I getting audio? Am I getting video? Let me watch the. Okay, I don't know where the audio is coming from. Anyway, I'm getting audio somehow. Where the audio is coming from. Anyway, I'm getting audio somehow. All right, I'm gonna go back and try to see. Where I was. It's live right now. Okay, that's where I was. Okay. Okay, so now that I see where I was, I'm going to go into I believe this one is a little better resolution. Okay, I did some of those. Going down, there's that one. A little better resolution here. I like that one, so let's look at that one for a moment. Let me make sure that I have the correct screen here. All right. I will have to wait a moment. For this to catch up with this. I'll make sure that so apparently right here. To about right here is a shadow on the board. Hang on 5 seconds. Yeah, a little bit more over. Okay. So let me shrink this down a bit. Okay, so it says if link AB has an angular velocity of 4 radians per second, like shown, determine the velocity of the slider block at E at this instant. Also identify the type of motion for each of the 4 links. I'm not going to worry about that second part. first, I'm going to do this using instant center. In an instant center sort of sense, I know point B moves in that direction because of this. I know point D moves in that direction because it is attached in this way. And I know this moves as such. I think this 2 foot is associated with this, so that would be 2 foot. This is rotating at 4, so therefore velocity of B is going to be 8. Now I'm looking at the point B, which used to and still does exist on A and B, but in my mind now I move to a BD. Again, I draw the perpendiculars to those velocities and find out they cross right here. So this is the instant center of BD. Now that I have the instant center of BD, what is the omega BD? And the reason I need to know this is, and how I will get this, is I will determine the distance from here to here, and I will use the velocity of 8 and that distance together to find this. In other words, velocity of B is equal to omega, and I guess I should have been more precise in this equation, and let me go back and put it. Omega AB R A to B. Now I'm out here looking at from the instant center. Now it just so happens this point sits on that link, but that doesn't matter. That link in your mind should be erased. This object could be thought of like this. Okay, here. I'm going to draw it and then erase it. I'll draw it right here. Here's the link. Somebody welded a part onto it. They pinned it right here. That point and that point are the same. This point and that point are the same. This point and that point are the same. So it's as if there is some rigid triangle here rotating about that point. Now, I could call that D, but I guess I will, since I have that picture and I have everything, it's okay. Now I've got a junked up drawing in which I'm going to try to draw over here unjunked. I'm not sure I can do a good job of that, but I can try. If I unjunk it, move it over, what am I trying to find? I know this is 2. I know from here to here is 1. This doesn't look right as far as that looks. Maybe it is. That distance and that. Okay, maybe I'm wrong. Okay. So it looks like it's out of scale, but maybe it's not. So 2 to 3 ways I could do it. I could look at this triangle. Let's try that. I know this is 1. I know if I drew a line straight out, it should be 30 degrees. So should look more like that. So if I take this line and move it up to here, I'll see it's 30 degrees. I don't care that this was 2. Yeah, it was 2 from here down to some point here, but this distance doesn't matter. This is still 1. This is still 30 degrees. So for that, and the fact of the matter is that's totally vertical. So my D here, okay, if this is 30, so is this. So cosine of 30, which is what that is, no, that's what that angle is the 1D. 1 over D. I wish it was sine, wish it was 60, but it's not. And so, I'm not good at this calculator, but I don't have a choice. .866 or D is equal to, I'll flip that, 1.1547. Now that I have that D, I come across here. The other thing is I know that was 8. So I have 8, and I have 1.1547. Now I can take this and flip it back upside down and put it like that, times 8 gives me 6.928 is equal to omega BD. Why do I need that? Well, because I really need this velocity. Luckily, D and B are only dB. So again, if I were to draw this link, this would be B, this would be D, and now it's rotating with omega BD is equal to 6.928. So if it's rotating about here, yes, you'll have a velocity like this, but you'll have a velocity this way, this one. Luckily, this one turns out, okay, so if I look back at the triangle, and I say the sine of 30, I'll say this is D2 is equal to oh shoot, that's not good. I thought it might give me a smaller number there, but it will. Anyway, the cosine was 1 over D. The sine is going to be D2 over D. Now D was this. So I got to, here's one way I could do this. Instead of putting an equal, I could multiply times D and end up with a D2. Because that's what I'm looking for. Turns out this should be a half. And this is not a derivative, it's just the D term, which is 1.1547. So now if I look at that, I take half of that, which might still be on my calculator, but might not. I'm going to start dropping a few digits. 1.1547. 0.57735. Okay, so that's the distance here of this length from here to here, 5.57735. Now, if I want to know the velocity of that point, because it is on link BD and rotating about that instant center, it's the omega of BD, which was this, times the distance from here to here, which over here I called it D2, which is that. So 6.928 times D2, which is 0.57735. Okay, I still have that number in the calculator. It looks like 4. Velocity is exactly equal to 4. And therefore, here's what is so interesting, and this is why he asked to identify the types of motion of the 4 links. This link, CD, is in pure rotation about C. This link, AB, is in pure rotation about A, because both of them are pinned. This one, since it has a velocity down and to the left, and to the left here, straight to the left, it's in translation mixed with rotation. What is interesting about this link is because the fact that this point must move directly to the left because it is attached to C, and because this one must move to the left because it's confined to sit in these 2 locations, then as a result, if you look at this and draw the instant centers, what you'll find is something interesting. Okay, here's your link. 2 velocities that look like that. Draw your perpendiculars. Find where they cross. They never cross. If they never cross, it's in pure translation. If it's in pure translation, then this velocity is equal to 4, because this one's velocity is equal to 4. So in other words, that's 4, and that's 4. So if you don't mind, I'm going to take a minute. I'm going to spin around, try to see if I can find the answer. Okay, this is 1673, and this one. So there it is, 1673. And I have no other choice but to move off the picture here, but you can rewind the video. Okay, I don't remember whether it was F1673. I think it was just 1673. Okay, so here it's hard to see it unless I got the camera off. And then what you see, there is your answer here, and that's in fact what we ended up getting. So let me hit that one back, and I wish I would have remembered the page number. don't know. Let's see. Oh, I was starting to look at that one the other day. Let me do that one instant center wise. And then we'll call it a day. Okay. This one is 1697. I don't know if I'm gonna get all the way through this. In fact, I need to roll it down a little bit. Not that much, so I guess I'm gonna have to shrink it. All right, there, that might do better. Okay, an oil pump unit consists of that, all this stuff cranks. Okay, if the crank rotates, that's this thing. At 6 radians per second, determine the speed of the rod and that thing right there. So, he's got a little bit of annoyance here. Okay, so I'm going to identify a couple things. One, this velocity is going straight up. What's its speed? 3 times 6. Omega R. So this is 18. That one's not 18. But what's annoying here, and I have no straight edges, so I'll try to draw a straight line. This is the pin, this is the structure, this is the pin. This one has to rotate at a funny, annoying angle. Draw the perpendiculars, then you get a triangle. Comes out here, say. Okay, it goes down 10 foot. Okay, what's your ratios here? 1.5 and 9. Okay, 10 divided by, hang on. In other words, what number do I have to multiply times that to get 10? Well, turns out if I multiply this times 6 2/3, I get 10. If I multiply this times 6 2/3, I get 60. So this is a 60-10. Okay. Again, let's look at this. This is 9. This is 1.5. So I just wanted to make, I want to make this triangle grow and then slide it right down here. How do I do it? Multiply that number times 6.23. I got to do the same thing here. If I do that, I get 60 and a 10. So that tells me right off, okay, this is the instant center of that funny link, CB, BC. Okay, so now that I've got that, here's one of the things I'm going to do, because I'm going to need this later, so I'm going to take that back off, because I'm going to need this distance in a minute. Okay, B equal omega R. If this is R, and that's B, then omega equals 2. omega equals to 0.3. What's this distance? Well, 60 squared and 10 squared and then the square root of it. Okay, hang on. 60. Square root of it. Oh gosh, that can't be right. That's 60.8276. Try that again. 60 times 60 gives me 3,600. 10 times 10 gives me 100. Add 100 to it. And then 3,700, take a square root, 60.8. That's the actual answer, apparently. So now, what's this velocity? Yeah, it's omega r. Omega this, r that, gives me 18.248, and then some more digits. Now we've moved from this length. We did an instant center on this length. Now we're moving to this length. Here's the deal. I know this is the instant center of this length because it's pinned right there. So I know this thing is rotating like that. Now I need to know this distance. Well, that distance is 9 squared plus 1.5 squared, square root. 9. I'm having trouble finding the square. Oh, can't you believe that? 1.5 squared, square root, 2.25. That's the r, this is the velocity. So the omega here times r is equal to the velocity. That is equal to 18.248. This is equal to 2.25, giving you a omega of 248, 2.25, giving you an omega equal to 811. Now I know this thing is 9 foot over, and it's going down the same speed that is. So now V is equal to omega r. Omega is 8.11. R is 9, assuming this whole thing is an arc. And times 9 gives me 73. Okay, if I'm wrong, I'm not redoing it right now, because I think this is going to be the last one. 1697, I get a value of 9. Yeah. $16.97. 18. Did I get 18? I did not get 18. So we're going to go back and work this one next time. Oh, wait a minute. 97. He's got VH is equal to 18. I've made a mistake somewhere. It looks like I made the mistake here. VE of 2. Okay, let's look back at that. I can take a few minutes to look back at that. 97 BE. Let's take a look at what I did wrong. he says omega BE is equal to 2. If it is 2, then by nature it has to be 18 because it's 9 over. So I've got the wrong value right here. Let's see if I can fix that. Hopefully I can line it back up. Hopefully I can find it to line it back up. Let's shrink it down, see if I can trace it out. There it is. I'm not sure. Let's see, shrink it down one more notch. And then possibly, can I move it over? I don't know that I can move it over, but anyway. So it's probably close enough. Maybe if I make it grow just a touch more. One more mouse scroll. Did that work? Yeah, now I gotta go. Okay. Well, we're close. So what did I do wrong? I got this. There's right. I got it. This has got to be wrong. That R has to be greater than 9. Somehow I got an R of 2.25. That's nuts. So somehow I goofed the computer up. The calculator. That's got to be. I don't know what I did. So let's see if we can fix that. Hopefully you saw it along the way. So let's go back. 9. Oh, you know what? I do this with memories. 9 squared. Okay, that's 81. Okay, that's fine. 1.5 squared plus 81, and then take the square root. So this R is 9.124, not that. 124. Divide this and this out to get the new omega. What do I get? That's the omega of this link here divided by, okay, 18,248. And sure enough, he's right. That's 2. Now, instead of this being 8, this omega of this link, okay, I know it's crazy, but this link is rotating about that. And I know it should be down a little bit, but I can't. Anyway, the screen doesn't like me. Here. Might be able to do it like so. Okay, that's a little bit better. So, in fact, this arm right here rotates about that point. I got that wrong. And as a result of getting that length wrong, I should have known that it's got to be greater than 9. Can't have a triangle where the hypotenuse is smaller than one of the two sides. So somehow I goofed that, probably lack of oxygen. Turn around, take the 9, put it in here. I get a 2. Now I get a 2. I'm sorry. A 2 times a 9, and I get the 18th, and that's the right number. So I'm going to call it good for right now. Made our way through it. And, oh, I forgot to pick up the mic. So hopefully you could hear me throughout the whole thing. Let's see. Let me turn on the stream again. There's nothing I can do about it right now. Can you hear me over here? Let's see. I don't understand this, but you can hear me all the way from over here. I don't know where the mic's coming from. Probably the whole room is mic'd. I don't know. Okay, we're done.